Hello, my name is Ramil. I'm a graduate student of Samara State University. Topic of my presentation is an effective scheme for solving a class of nonlinear boundary value problems of stress concentration through quasilinearization method. Modern computer technologies and algorithms provide fast and accurate numerical solutions of complex systems of nonlinear ordinary differential equations. Nevertheless, the problem of constructing analytical approximate solutions of nonlinear problems becomes even more urgent at the present. Apparently, a reasonable combination of computer technologies and approximate solutions or reductions of nonlinear systems of differential equations gives a promising way of studying physical, economic, biological problems and other problems of natural science. Nowadays, the quasinoidation method is promising approach in the framework of which the solution is constructed through skillful combinations of methods of linear approximation and the use of possibilities modern computing systems. The quasinoidation technique linearized the nonlinear boundary value problem and provides a sequence of functions which is general converges quadratically to the solution of the original equation if there is convergence at all and often has monotone convergence. The solution of the original nonlinear boundary value problem can be obtained through a sequence of successive iterations of the dependent variable. Let's start from example. It's a problem of steady state creep of a rotating disk. We have a disk rotating with angular velocity omega, and it have external and internal radiuses. Mathematical statement of the problem: strain stress displacement equations can be written as equation 1, equilibrium equation written as equation 2, and capability condition can be written as equation 3. Equation 4 is the boundary conditions. For material subjected polar law creeping, the constitutive equations can be written as equations 5 and 6, where function f is a power law given by equation 8. Linearization of constituting equations 5 and 6 leads on rearrangement to equations 9 and 10, where coefficients a and b is coefficients of linearized constitutive equations and evaluates on current estimate. Combination of this system gives a system of linear differential equations, and the results of solution of this problem given by quasinoidation method illustrated by figure 2. We see the convergence of stress components, and figure 2 illustrates convergence of strain components for n equals 7, where N is a constant of power law creep. Next problem is a steady state creep of a whole plate under uniform tension. Geometry also described by the polar coordinate system, and material behavior are described by Bailey-Norton law. And also using quasilinearization method, we have these results. Using quasilinearization method, 4 iterations are calculated, and we see the convergence of stress components to the limit solution. Figure 6 illustrates comparing approximate analytical and numerical solutions for constant n equals 7. Its solutions, numerical solutions given by Runge-Gutta-Fehlberg method, and numerical solution given by results from Simula-Abaqus soft package. And red line is results given by quasilinearization method, 4th iteration. And it is worth to note that tangential stress reaches its maximum value not at the circular hole but at the internal point of the plate. Using Simula-Abaqus soft package, we obtain several numerical results for n from 2 to 10 in Bailey-Norton law. Figure 8 illustrates Simula-Abaqus calculating results. And last problem is a steady state creep of a hold plate under uniaxial tension. Also geometry are described by the polar coordinate system, and material behavior are described by Bailey-Norton law. Let's see the equations of the problem. It's 3 strain displacement equations, 1 capability condition given by equation 4, and 2 equilibrium equations given by equations 5 and 6. And 3 compatibility conditions for material subject to polar law of creeping. The constitutive equations can be written as equations 7 to 9. Linearization of constitutive equations 7 to 9 leads on equations 10 to 12. And we have a system of linear partial differential equations. In the every iterations of quasilinearization method, we calculate stress components in the next form. And there is results illustrated by the figure 10. It's a convergence of stress components for n equals 3 in Bailey-Norton law. And we also note that for this problem, also tangential stress reaches its maximum value at internal point of the plate, but not at the circular hole. results for this problem given by similar abacus package illustrated by figure 11. And finally, conclusion. The approximation solution of the problem for an infinite plate with central circular hole under cube regime is obtained by the quasilinearization method. Four approximation of the solution of the nonlinear problems are found. It's shown that with increasing the number of approximation, the solution converges to the limit numerical solution. It is worth to know that the tangential stress reaches its maximum value not at the circular hole but at the internal point of the plate. Two approximations for problem to the plate under uniaxial tension are found. It is also shown that quasilinearization method is an effective method for nonlinear problems. Thank you very much for your attention.